Alright, it's time. We are going to be moving today, but it's going to be in a good way so that you can get your questions answered. Hey guys, we have 23 students in this classroom and only 20 of us have signed in 5 minutes into class. That doesn't make sense. Or not applicable is usually what that means. Wait, right? 4, 8, 11, 15, 19. I lied. Kai is not in. She's getting her book. Okay, I lied. We're good. Okay, so how to do upper and lower bound without a calculator. So we will actually look at that. That's one of the things I'm going to talk about with the understanding check. Okay, why are there so many word problems? Well, because if we're going to do statistics and math in general, man, it's really helpful if we look at the real world. Otherwise, what's the point? We're just wasting time and effort. The whole point of math is to make sense out of the real world. Everything that's ever been discovered. Can you reteach the whole from the beginning? That's what tutoring's for. Can't do all that in 90 minutes. That's also why the videos are on YouTube. Type of samples. If we have time getting through all this stuff, we can talk about the type of samples. When you say type of samples, whoever said that, type like sampling methods? Right, those are sampling methods, right? Collecting a subjective sample, right? Collecting a random sample. I think we also talked about a convenient sample and a volunteer sample. Right, everything but the random was biased. So we'll review that a little bit. Finding a z-score, exactly when to use the z-score chart or calculator. You can always use both. For that person who asked that, we'll talk more about it later. But you can always use the z-score chart or the calculator. Personally, I'm going to use the calculator for sure anytime I have an actual upper and lower bound. And also when the decimal repeats. And so we'll look at some examples of that today. Yeah, relative frequency. That got a lot of us. It's in your book. You'll see notes, activity 1.1. I try to tell you every question where it came from. So we'll try to go through these. I don't know how to find z-score answer type problems to make it more clear. Hopefully today's stuff will review that. If you have questions though, ask those questions. There's no point in hating z-scores because they're there and honestly it's a formula. Don't make it harder than it has to be. It's the value minus the mean divided by the standard deviation. That's it. Don't make it harder than it has to be. So a lot of nothings. Alright. Why can I not understand the difference? I don't know where we're going with that, but if someone wants to say, hey, that was my question, and continue that question. Alright. Push on the door, Kaya. There you go. I'm going to try to answer all these questions. I wanted to glance through them quickly before we got started. Actually, I don't need that. So, if I don't answer a question, let me know. That's not supposed to be there. Alright, agenda. We're going to... Yeah, let's do this wrap up, normal distributions and probability wrap up. There's only one more lesson out of the book. It's activity 4.2, some page. We're going to have an understanding check discussion, a homework discussion, and then any final questions from there. M5-48, that's where we're looking. Okay. So I will point out how different are probabilities and those percents, or at least the process of getting them. Are percents and probabilities different?
Not really.
The only difference is that the probability is between 0 and 1, and that's talking about kind of like the future, but it's calculate that probability the same way. I mean, we still are getting z-scores, right? We're still using the calculator to find the area underneath the curve. We're using the table. It's no different. That's why, remember, the name of this lesson was tomato, because we're still talking about the same thing. Right? Okay. Alright. So here are the objectives. Determine the probability of an event described by a normal distribution. Okay, so don't forget, one of the things that we hopefully learned yesterday that would have helped some of us on the understanding check, and I didn't realize this was a mistake until I looked at the understanding check. When do we want to use the empirical rule? When you have integer values for the standard deviations. By the way, what is the letter that we use to represent the number of standard deviations a value is away from the mean?
S.
The number of standard deviations. That's the z-score. What a z-score is the number of standard deviations that value is from the mean. That's why when we look at the z-score formula, what's the numerator?
Value minus the mean.
Right? Value minus the mean. Isn't that tell you how far that value is from the mean?
Yep.
When you find that difference, that's telling you how far that is from the mean. Then I divide by the standard deviation, right? That will then give me how far the value is from the mean in terms of standard deviations. That's what a z-score is the number of standard deviations that value is from the mean. For example, I'm making this up. Let's say I have a mean of 4 and I have a value of 6 and the standard deviation is 1. Okay, how far is the value from the mean? 2. And every standard deviation is 1, so how many standard deviations is that? That's 2 standard deviations, and it would be above the mean because it's positive, right? So what if I change this to a 3.25?
It'll be negative, right?
It would be negative, right? Because it's below the mean. And how far below the mean is that value?
0.75.
So negative 0.75. And when it's divided by 1, that tells me that it's negative 3/4 of a standard deviation from the mean. Or 3/4 of a standard deviation below the mean. That's all we mean by z-scores. And so integer z-scores, we can use the empirical rule. When they're not integer number of standard deviations away, we have to use a, if it's not an integer, we got to use what?
I ain't gonna lie, I don't know.
The calculator or the table once you figure out the what? The z-score. If it's not an integer number of standard deviations away, you have to calculate the z-score and then either use the table or use the calculator to find the area underneath the curve. That's it. Laisha, does that answer your question?
Yeah.
Okay. What did you say, Anthony?
What's the answer?
Say again.
What's the answer?
To what?
The question we just asked.
I asked, when do we have to use a z-score, right? When it's not an integer number of standard deviations from the mean.
Calculate z-score?
So you have to calculate the z-score, and then you use the calculator or the z-table. That's it. If it's not an integer number of standard deviations away, we use the z-score. You got a question, Alicia?
No.
You good?
Yeah.
You sure?
Yeah.
Okay. Last detail is this. What do you really need to create with the z-score when trying to calculate that area every time?
Repeat that question.
What do you need to create every time when you're calculating that z-score and you're trying to find the area or the percent? Yeah, draw that normal distribution. That's going to help you identify your lower bound, your upper bound, all those things. Draw your normal distribution, whether you're dealing with the empirical rule or you're dealing with z-scores or whatever, the graph will help you significantly. All right, so we're here on activity 4.2, comparing tomatoes. Brad and Toby both plan to enter the county tomato growing competition. Each person who enters the competition must submit a basket of tomatoes. The judges randomly select a tomato from each contestant's basket. According to the rules of the competition, a golden tomato has a diameter between 4 inches and 4.5 inches. The diameters of tomatoes in Brad's basket are normally distributed with a mean diameter of 3.6 inches and a standard deviation of 1 inch. The diameters of tomatoes in Toby's basket are also normally distributed with a mean diameter of 3.8 inches and a standard deviation of 0.2. inches. When the judges randomly select a tomato from their baskets, who is more likely to result in a golden tomato? Now, before we get started on that, I have to ask an important question. What do you think who might be more likely? What's your reasoning for Brad?
It's the same.
Okay.
His mean is a little bit lower, but his standard deviation is a very good amount higher, so you probably have a bigger chance.
Okay, so it's not just about the mean, right? The fact that he has a higher standard deviation might make it more likely that he has that golden tomato between between 4 and 4.5 inches. But I will point this out again because students are going to get thrown off by the fact that it needs to be between 4 and 4.5 inches. What should you probably do to help figure out that area, that probability? Shade it, which means you need to create a graph, a normal curve, okay? I would also, if I were you, get in the habit, which I did not see most of us doing this on the understanding check, label your graphs. Put a title with it. It makes it easier to keep track of things. Let's get to work. Let's try to knock this out in the next 10 minutes, within the next 10 minutes, and then we'll have a discussion. If I see us getting done before that, we'll get going quicker.
Why is she not here today?
She's originally coming on Monday and Wednesdays. She's still taking classes at UA.
Why ain't know that?
She's not a full-time intern. She'll be a full-time intern next semester. What's your question?
Okay, you know, because I know.
Okay. Really quickly.
Oh my God, I didn't even see that.
Why or something like that?
No. The diameter needs to be 4 inches. Thanks. I want to pause for I want y'all to understand. I know you don't have great ideas because I've seen y'all's understanding checks.
Oh my God, I don't
Y'all know
do
this
that.
is why this group that y'all don't talk as much as other people.
You this though.
It makes the math more fun, first off. Second off, it's going to help you get your ideas out. It's going to help me listen in on what we're misunderstanding in the moment, things like that. And also share ideas. Every time you talk, it's good ideas. Talk more. Frankly, I don't know that I've heard you during a whole class discussion once, okay? Let's get involved in the conversation. Y'all have good ideas. Use them, okay? Okay.
Okay, so the golden tomato has a diameter between 4 and 4.5.
What's on, Salita? Step up. Get your drawings down there. Look at Salita's drawings.
They have a better.
Okay, you.
I have a meeting at 12 until I have to go to the IRS meeting next meeting. And my enrichment is during the first one. You can come during your enrichment, but it'll just be doing all this stuff again.
With this being
During third block.
that,
Whole bunch of other students. You want me to name all 25 of them?
Yes.
No.
My
Mine
enrichment like from 1 to that's right.
I will say, I feel like there's one more thing that I would draw. I would put in your curve. The z-score values, those integer z-score values, right? I would show those corresponding things, right? Really quickly, yeah, make sure you have that as access. Don't forget, so like, even before you start doing those calculations, right? So there's your mean, but go to your point of inflection, and there's one standard deviation, right? And so one thing I will say is you're drawing this almost a little too steep. So it's making it hard for you to really see what it's like. So this is better. You don't want it quite so steep though. You want to go nice smooth increase, nice smooth decrease. So notice there's my mean, and then here's that point of inflection. Notice how I can do that distance 2 more times, roughly. And that's going to represent like 3 standard deviations per rank. And it's going to help make it easier to graph these things. Does that make sense? Okay. So it's drawing it out helps so much. Okay. But so these guys can get stuff going on. Yeah. What
I know. You go ahead with her.
I'll tell y'all.
Okay, so you were doing that one first. You were doing Toby's? So make sure you label Toby's, right? I assumed you're doing the top one.
Pretty much, you ain't even gotta do all that with
So the lowest, right, so that's something you want to notice that the lowest part for a golden tomato is 4, right? And so you would, and so looking here, notice how you drew a line at 4, right? And then is the max 4.5, right? So you want a little bit less than 4.6 and you shade it between 4 and 4.5, right? And so we would need to find that area. So once we draw it out and we see that there, it makes it way easier. And then yeah, you would use this right? Now, I'll point this out. It looks like you only did close to X for each, right? But we have a lower bound and we have an upper bound, so you need. Does that make sense? So, well, you just have to do the z-scores. Right? You don't have to do the calculator. It is easier to calculate if you have a lower end. See,
Why do you do this?
we'll talk about how you use it.
It's not, it's fine.
Down low and does it.
Straight line, each straight 5. It's not sitting off, I swear.
I passed these out to y'all's group, right?
Yeah, right.
That's what I'm trying to figure out right now.
Now I'm gonna go draw.
Something guys.
Minus 0.7.
So first off, x equals 3.5. So remember your z. Okay. So write out your formula first, right? So z equals.
That's like that's the z-score, which is
S for standard deviation. So remember, the value would be the thing that you want, right? So what would be a value for Toby? Okay, so look at your shaded region, right? Isn't 4 one of the values? Well, it's not that you can pick any, you actually have to do 2. Because you see how you have a lower bound for that shaded region? And you have an upper bound for that shaded region. So how many z-scores do you need just for Toby, or just for Brad?
4.2, 4.2.
It's not that hard.
You have 2 bounds, so you need 2 z-scores. So you need a z-score for every bound.
So everybody would say high.
You did, like, the graph so quick, but like, what have you done since then?
That was already designed as label.
But what are we trying to find?
And that's the thing.
Read the directions. What do we want? We want them to get a what? Okay, the probability of what though? Like, what are they looking for? Okay, so what is a golden tomato? It tells you in the problem.
4 inches.
So between 4 and 4.5 inches, right? Can you draw the 4 and draw a line where 4 is on that graph? Can you draw a line at 4.5?
So how do we know whether or not we do lower bound or upper bound?
Okay, so you draw your line. Your lines for the 4 and 4.5, and then those are your bounds. But
Then you use what?
so first, so you see how you drew 4 and 4.5, and you want a tomato between those two, right?
Wait, so I don't.
So that's the shade, that's the region that you want.
That's what you said.
Okay, look out.
I get the calculation down.
I'm not lying,
I think for the standard deviation, it's
but I wouldn't.
Wait, so say for Toby, how do I put in Toby?
This is why I told y'all every time what you need to calculate
No.
before you start doing anything with the
The lower
calculator.
bound?
You need your z-scores, right? So what is the z-score, right? So that's the x value of 4, that's the x value of 4.5. You need the z-scores for both of them because they're both bounds.
So I gotta plug them both in.
Plug them both in. Okay, so be clear with your language. So you need to substitute those values into the z-score formula, correct?
You make me feel like I'm wrong.
But you need to be clear with your language. You got answers already? Okay? So, some of y'all erase that, put the information for Brad up on the board, and when you put the information for Toby on the board. Lower bound is the lower number. It's just the lower number, right? But here's the thing, if you're going to use a mean of 0 and a standard deviation of 1, you can't use Hold on 1 second. What do you need to use if you're looking between 4 and 4.5? You need not a Z chart, but you need a Z score.
That's for deviation.
Have you found the Z score for that? Have you found the Z score for 4.5?
Deviation or two.
Somebody.
Put it in as like.
Oh, that's why I messed up.
Okay, but have you done it for Brad? Because it's not as easy for Brad.
Yeah, I haven't gone.
You need to do that for both of them. But find out your Z scores. Hold on 1 second. The other question, what was it? Show me all the work you did.
Even the explanation
You can show me the graphical work and the algebraic. Graphical work and the algebraic stuff you have to do. Maybe like what you put the calculator and all that stuff. So you don't have to write sentences. Just draw your curve. Right? And y'all can all collaborate together and get up on
But like I
Is that
yeah. Thanks, Mr. Kenny.
Look at it right now. Wait, so here are the two. Look at the sheet.
Oh, 3.6.
It's 3.6 shaded.
I mean, I know. Yeah, it's in my mind. It's something.
Okay. But look at the shaded region. No, because you need it as a Z-score. So what is the Z-score as?
But it's say between 4 and 4.5.
Right, but have you calculated the Z-score?
No.
This is why I tell you as well. Now, find the Z-score for this. So what is the Z-score for this? Translate. So yes, it's going to be for me, that person is 0.4. Positive 0.4. So this lower bound is Z 0.4. Now find your upper bound as a Z-score.
Hey, Mr. Kenny, I think I'm on the back there.
I'll be over there in a second.
Hey.
Does that make sense? Okay. How are you all before I move on? So, why did you use 4.5? Right, but you did 0.4 here, didn't you? And I would check this again. Because remember, the value is 4.5. Check that Z-score. Right, because that number is above 3.6. It can't be negative. You must have look at what you look again. You accidentally did times negative 3.6, right?
This one is 3.8.
Because that's the mean. That's the standard deviation for Toby.
It's the kidney.
Hold on. The standard deviation for Brad was 1. The standard deviation for Toby was 0.2. Where does the standard deviation go in that formula? See, this is why you write out the formula and look. Where does standard deviation go? She's literally standing in front of it. Hold on 1 second, Brandon. Where does the standard deviation go in the formula? Listen to my question again. Where does standard deviation go in the formula?
At the bottom.
So then what is Toby's standard deviation? Look back at the problem. What is Toby's standard deviation? Okay.
So confused.
Where do you put standard deviation? So then where does 0.2 go? Right here again. 3.84, isn't that really standard deviation? So the standard deviation was 0.2. What goes there is the, you're not even looking at the formula.
Yeah, that's what, that's what.
Use the formula and talk with each other. I'm gonna go check on another group. I'll be back in a second, guys.
Hold on, you said it's 829.
Yeah, they're all in turn.
How you gonna leave her?
Now what do you do?
That just ain't fair. Hey, what's the
Which is the table. Okay, so cancel. So we're gonna talk about this again, but what I want to know actually is, on the table, doesn't it always give you the area to the left? So looking at the 0.9, the area completely to the left is this, right? But do you want all of this area? And this is why I always shade. You just want this, right? Right, we don't want this, so we're gonna take this out. Yeah, but the probabilities, that make sense. So we're gonna have a conversation about how to use tables, but if you're using the calculator, have conversations with us, alright?
Okay,
You definitely don't have your hands before Brantley. She had her hand up before I got to that group, but that group had their hand up before she did. So come at me one more time while I'm trying to help all my students. You're a liar. I literally just called her out on her bullcrap. What else do you want me to do?
Oh, you thought he ate that. For real.
What is, so X is your value, what is X bar? Have you talked to your group? Because I know that's not true. I know Samayan and Anthony. I know Anthony knows what X bar means.
It's me, dude.
Oh, look at that, he did know!
No, you didn't. You did not ask me.
X bar is mean. What does S stand for?
And I got asking that particular question.
What does S stand for?
He said,
Because you weren't clear about your word, your language. But focus on the stuff here. Okay? You left it, or whoever left it. You left it. Because it was just underneath the desk. Oh.
Well, how would that be? Just grab the background out of it.
you're gonna get them in a different area.
Sure, that's right.
Hey, we got basketball. Yeah.
Is that a Z or is that the
No, I just write down.
Why are you touching it like
Y'all gotta be careful. See, that's the probability. That's not the Z. That's the probability. So just put, I would just say probability.
No.
Oh, that's all, okay, yes, that's me. Okay, that's all.
He's more like.
Right, so this is why, well, see, before that even, what I would have done, and I would probably try to start this out.
4.4.
It takes time.
Oh my
I
God.
always want to spread it out. It's got just a little bit more spread out. It's okay if you don't. See how hard it's going to be? So we have a 4 in here, and we have a 4.5. See how skinny that is?
So do we have to do that?
There's my 3.6. And 4.5 would be about here. So there it is. Now remember, we want to have these. See how we have a lower bound right there? That's why you need to go for Z-score. Lower bound. That's the Z-score.
I'm taking 3.
You can use the calculator or the table. The calculator's not here, but we're literally about to go. Okay, so I just did. Thank you. Thank you, thank you. Let's bring it up. We're just about to go over at this point. Okay. So you're good. Alright. So, guys, I will say this. Some of us need to definitely study and get quicker at this, do some more practice problems tonight. It's seeming like we're getting there on our conceptual understanding, but you got to practice to get faster at it. Because you will have multiple problems tomorrow on the test. So, when we look at this, what is the first thing that you should do to make your job easier?
Shade.
So you need to create the graph. You need to draw your histogram to get started.
Yeah.
And I cannot emphasize this enough. Do you know what the one thing is missing from this histogram that I would want?
Standard deviation.
I want those standard deviations, the z-score values as well. The mean would have what z-score value? 0. Because for all of us who are freaking out about what the standard deviation is, if you had taken the time to draw this out, you can very clearly see how much is one standard deviation there.
0.1. It's 1.
3.6 to 4.6 is
Yeah,
1. Because y'all are using your standard deviation to draw that histogram. Okay? So notice one standard deviation is 1. Okay, so from there, notice we are just approximating, but we are looking between 4 and 4.5. Once you identify that, you want between those diameters, right? And so that's the shaded region. And you got to pay attention. Usually up to this point we've done how many z-scores?
Plenty.
Per problem,
Oh,
we usually only did
wait. Maxine.
per distribution, we usually only did 1 because remember, we usually were looking at this or to the left, or at that value or to the right. So notice there's only 1 bounding, really. The other side is always to infinity or negative infinity. But when we look at these, how many bounding values are there?
3. 1.
You're looking at me instead of at that graph.
What I'm looking at?
Right here. Look at that. How many values are bounding the shaded region?
1.
2.
2.
How you get 2?
1, 2.
Oh, I thought Okay, I see it.
There are 2 values bounding that shaded region.
You right.
I know. Okay, so learn from that. Okay, so we got to learn from that mistake, all right? So how many z-scores do we need?
2.
2. If you are struggling with the formula for z-scores with the symbols, don't forget, because some of us aren't doing this, and Hudson did a great job of talking this out if you had paid attention to it. It's a value minus the mean divided by the standard deviation. It doesn't matter what set of symbols you use, that's what the z-score formula is. It's whatever value you're looking at minus the mean divided by the standard deviation, which is why you can use x minus x bar. That's a value minus the mean divided by s. Or if you're dealing with a population and parameters, it'd be x minus that Greek letter mu divided by the Greek letter sigma for standard deviation. X bar is mean. And by the way, why do you think we use s for standard deviation?
Because it's the simple way to do it.
Why do we use s for standard deviation?
I'm sitting
Oh, standard starts with an S. Literally, don't make it more complicated than that. Standard starts with an S. That's it.
Ain't no way.
I'll even point out, the Greek letter mu starts with what letter? M. So mean. The Greek letter sigma starts with an S. So standard deviation. That's why they do that. Don't make it more complicated than that. Yes, Madison.
Okay. there's no tutoring after school?
Not on Thursdays.
Wow.
Got tutoring tomorrow morning.
I need you, man.
Y'all, you've had 2.5 weeks to take advantage of the tutoring times. I know some of us came yesterday, and I think that was helpful. However,
I gotta work.
we've had 2.5 weeks to come in and get tutoring if you needed it. Okay?
I'll be there tomorrow. I think.
I'll be here in the morning. You will have the videos on YouTube. You should have your notes in the book. We got to learn how to start using our book to actually study outside of class time.
What do YouTube link here?
Literally search my name. Nathan Kinney on YouTube. It is the first channel that pops up. You go to the playlist. There's a geometry one and an algebra 2 one. You're going to go to algebra 2. Okay? Don't make it complicated. I try to make it as simple as possible. Alright? Nathan Kinney. That's it. Search for it on YouTube. It'll be there. Alright.
You need to get your views up, dude.
That's not my job. It's your job to watch it. That will get the views up.
I recommend you
That's like
editing
an hour
video so you ain't gotta watch all this. That's a lot to scroll through.
One of your videos got 6
Do you know
minutes.
how much time it takes to edit those videos?
I
That's
do it
enough.
for you. She lying like love.
You don't watch it in the first place.
She lying.
I hate you.
You know how many people come to me to edit their stuff, man?
Okay. I ain't got the money to pay for that.
That's
How you gonna put like a?
Then
Put a little
you're a fool
subscriber.
for
You
giving
got
all
like
that free
24
time away.
subscribers. You should let us shout you out like Mr. McD. He has like 80,000.
What's the
That's
point
cool.
of him getting
Who is
views?
Mr. McD? Mr. McDonald.
Oh.
He got how many?
Alright.
80,000.
So, guys, we gotta focus, okay? So there's our z-score values. Once you have those z-score values for the bounding region, right? We need to get the probability, which means we need what?
The Z.
Normal CDF.
Okay, but what is that normal CDF trying to find?
The probability. The Z-scores.
Repeat what you just said.
Okay,
No,
I need
the percent, the area.
pause and listen. If I ask you for normal CDF, you should not jump to saying it's going to give me the z-score. This is the z-score. We have the z-score.
The area under the curve.
Thank you. Now the area underneath the curve is the same as the probability. The area under the curve is what gives us our percent. Okay? But we go from a z-score to the area under the curve. Yes, Tori?
Is the area under the curve bad?
It's the shaded region.
Oh.
The area under the curve that you're looking for is literally the area that you shaded. That's area.
Oh. I love that.
You see how there's a curve?
Yeah.
It's this shaded region. That's what you're looking for.
I got lotion.
That's the shaded region under the curve.
So is that area underneath that?
So this shaded region would be the area under this curve.
Okay.
Okay, is that helping now? Alright, guys, the shaded region is the area under the curve that you're looking for. Alright, so now notice we have a z-score. That's not supposed to point there. We have a z-score here, which, by the way, is that a lower bound or upper bound?
Lower.
That's lower because it's to the left. That is the leftmost part of the shaded region. That's a lower bound of 0.4. This right here then is the upper bound because it's the furthest shaded to the right, and that's a z-score of 0.9. I'm going to show you two things. One, let's use the calculator. Okay? So,
Don't say that again.
okay. I think for the most part we should be good once we have the calculator page. What's the first button to press? Menu. Everything runs through menu.
5, 5, and then 2.
So you can either do probability or statistics. But here's the thing. Stop. Stop just memorizing numbers. Look at what it says. We're dealing in statistics, right? So yes, 5 or 6, probability. Then, don't just say a number. What's that next 5 correspond to? Distributions, because we're dealing with a, what is this called?
Distributions. I mean, a
It's a
curve.
normal distribution, or a normal. The shape is a normal curve for the normal distribution, which is why we go to
What are you talking about?
distributions, and there's lots of distributions here. We're using normal CD. Nope, not inverse. Sorry, click the wrong thing. So distributions and normal CDF. If you've drawn it out, you already have the lower bound. What is it? 0.4. What's the upper bound? 0.9. And if you convert it to z-scores, you don't have to change the mean or the standard deviation. It's 0 and 1.
0.16.
Yikes on that probability. We gotta pay attention. I want to pause and I do want to point this out. I was wondering if this would be right away, because what percent of data is between the mean and 1 standard deviation? The mean and 1 standard deviation above? 34%, right? Because it's half that, 68. So use that, right? Use the empirical rule to help make sense out of things. I knew it had to be a little bit less than that. So I'm not sure what happened when we put it in, okay? But make sure we pay attention on the calculator. So, any questions about putting it into the calculator? We good? All right, now we're going to talk about the table side of it, right? Which Group 5 did very successfully. Because here's the thing, I'm going to ask you to use both the table and the calculator. Brantley, did you have a question before we get to the table part?
Yes.
What's your question?
How do you know when you like change the upper bound or lower bound?
So that's why you graph it, right? So remember, we're looking for this shaded region. What is the lower bound to that shaded region, meaning the leftmost bound? See how it's this line right here? So it's that z-score you already calculated. That's my lower bound. Upper bound means the rightmost to the shaded region, which is this line, which is this. If, right, if we're looking here and it was all of this, does it ever quit shading to the right? So there would be no upper bound, and that's when we put it in like 100 or something. When it shades all the way to the left, that's when it's like a negative 100 because it never quits going. Okay? Yes, Tori?
So lower bound and upper bound are z-scores?
Yes.
So
Yes.
Is the Toby one, is that considered it's shaded all the way to the?
That's a great question. We'll get there in just a second. Okay. But looking at the table, I want to point this out. If you go to the table and you look at a z of 0.4, and this is why I gave out all the tables, or I gave everyone a table, and I do want to point this out. This is the z-score chart that is given on the AP exam. I want you to notice, it has a little picture there to help remind you, no matter which one you're looking at, it has a z-score. In which direction is it shaded? To the left. Whenever you look at a z-score table, you're looking at that z-score and the area to the left. Okay? So, if you look at a z of 0.4, what's the probability? 0.6554. Okay? If I look at a z-score of 0.9, what's the probability? 8159. Okay? So, Brantley or somebody in Group 5, what did we have to do with those two numbers to find the correct probability?
you have to subtract them from each other.
Can you explain a little bit more about why that is?
Because if you have to subtract it because you're trying to find from one number to another, in fact, trying to find the middle of that instead of going all the way to the left or to the right.
Okay, so remember, and that's what we want to note, the z-score, or that standard normal curve, the z-score table, only gives us the area to the left. So that's 0.8159, that's from 0.9 all the way to the left. What do I not want?
All the way to the left.
I don't want all the way to the left. In fact, what section do I not want?
To the left.
To the left of what?
And 0.4.
Not to the left of the median, to the left of what?
0.4.
0.4, right? I don't want any of this. I got to take all that out. Well, what is all the stuff to the left? That's 0.6554. So if I take 0.8159 minus 0.6554, what do I get? 0. What? Huh? Is that the same thing as the calculator?
Uh-huh.
Uh-huh. Yes, JC, go for it.
Okay, so you have the error from 0.9, right?
Right. Why isn't there? Well, that is the area to the left of 0.4, but remember that's the area that I don't want. So I take that area away from the 0.8159. Right? So whenever I look at that z-score table, it's taking this and everything to the left, and I just don't want what's to the left of 0.4, so I take that away. Okay. Yes, ma'am.
So find 0.855 now. I mean 0.159, I mean 0.85. So find the probability of 0.9. Did you switch the numbers in the calculator? How did you find that?
I use the table. Pick up a table, look at the z-score of 0.9. Now I can find it in the calculator. I will point out, look, Salita, to answer your question a little bit, I can find it in the calculator. If I'm doing the calculator though, I'm doing 0.4 to 0.9. But if I'm looking all the way to the left of 0.9, what's the end of the shaded region? Not. It's going to keep going, isn't it? So it's going to go to, not infinity, negative infinity. So if I were to use the calculator to look at that, I would look at probability, distributions, normal CDF. If it keeps going, negative infinity. You can leave the negative 9, E999, right? And then the upper bound would be that 0.9. I hit enter. Isn't that the same as what we found in the table, 0.8159?
Wait, but you did that. Why?
Because you were asking how would I find that in the calculator.
Yeah, I mean like, why did you leave it as the negative?
Because you were asking how would I get that number from the calculator.
I mean, but like, why did you do it?
Because I was answering your question.
Oh, my, you can understand what her line is.
I don't know how to word it so you would understand.
See, that's what I'm saying. You know how when I have a question, I don't know how to ask the question? Like, I don't know what to ask?
But pause and let's go back. Okay, we got to get going so we can look at understanding check and
I
other
think
things.
I'm asking you, why did you just do that?
I use the table. This
Yes.
is the method to use the table to get that probability.
Yes, but why? You know how when you did 0.4, you put 0.4 and 0.9 to get that?
Uh-huh.
Why did you use
She's
negative
saying
infinity
how did you get
instead?
those numbers and how can you put them in?
Okay, right?
Stop talking for her, please. Sorry, I appreciate you trying to help, but I need Salita's ideas. You know that the first time we did it, we were just straight up using a calculator.
Yes, and you use 0.4 and 0.9.
Right.
But this time you use negative infinity and 0.9. Where did you get negative infinity from if it was only
Okay, first off, I didn't use negative infinity originally. All of this came from the table. Pick up the table that I put on your desk. Look at the z-score of 0.4. You find it? What's the area to the left of that 0.4? Look at, Kathy, can you look on over there and show her?
Okay, I see that. I see
Okay.
that.
Look at the 0.9. What is the area to the left of 0.9?
I don't actually see it for real.
So you just looked at 0.
What?
You should just walk to her desk and.
Yeah, I'm gonna have to answer your question later.
Forget it.
Not forget it, Salita.
Yes, forget it.
Salita, because you
Yes, I
walked
see
in.
that, but
Salita, stop. You walked in and the whole principle was that you were capable in my classroom. So don't forget it. I'll sit down with you, but we gotta get going on the next part. Okay, so for Toby, what was this z-score? 1. And so someone was asking, does it keep going? Well, no, because remember it stops right here at 4.5, and what was that z-score? 3.5. So would it be going to infinity even with Toby? It would be going to that or the value of 4.5, right? Remember that is our value with a z-score of 3.5. So how do we calculate z?
Oh, it's.
Notice how it says z equals. How do we calculate z? So the value is 4.5. What's the mean? What's the standard deviation? That gives me 3.5. Don't make it more complicated than that. If it's a z-score, I use that formula.
That wasn't easy, wasn't it?
Okay? Is that going to help her? Look, I'm just saying, if it's a z-score, I'm using that formula. That's all I did. Okay? And don't forget, like, and I will say this, I didn't actually need the formula for this one because I know if I'm looking at 4.5 and my standard deviation is 0.2, right? I know that 4 is 1 standard deviation, 4.2 is 2 standard deviations, 4.4 is 3 standard deviations, and then I had 0.1 to go, which was a half standard deviation, right? Because the standard deviation was 0.2, that 0.1 to go is half a standard deviation. So remember, that is telling me how many standard deviations that value is above or below the mean. And so I knew it had to be 3.5. But use that formula every time. Okay, so calculator, menu, probability, distributions, normal CDF. Okay, so it was from 1 for the lower bound to 3.5 for the upper bound. Do I need to explain lower and upper bound for Toby at all?
Yeah. I know what about.
So remember, lower bound is the leftmost part of the shaded region, right?
So
what
why
was
is,
the lower bound?
why is it not changing? Why you changing?
Oh, it's infinite, the lower bound is infinite.
True.
Guys, look, stop. Shaded region stops here at 4.
Yeah.
That's 1 standard deviation above the mean. That's the lower bound. So what's the lower bound I put up there? 1.
Why you put the upper bound as 3? Oh wait, is this here?
Because that's the mean.
Hold on 1 second. Guys,
Well, now I'm confused because I thought the lower bound, since that's to the left, would have been everything. Never mind.
Madison, look at the shaded region. Tell me where the shaded region stops.
I thought it would have been everything past.
But look at the shaded region.
It goes
Yeah,
to
I'm looking
4.5,
at the
man.
Wait, you know a golden tomato is only between 4 and 4.5. Right?
Yeah.
So I went to 4, that's a z of 1.
Yeah, you went to.
I went to 4.5, which is a z of 3.5.
So nothing outside of 4.0 and 4.4 matters.
Isn't that what it says in the problem?
Exactly.
You know what? Yeah, I don't have any more questions. Thank you.
But, guys, pause and listen. The reason I say it like that, I need you to pay attention to this. Y'all are not even finished, like you're just trying to do work without going back to what the problem is asking. Go back to what the problem is asking. If you don't do that, it's going to make this next to impossible to do. It's there. Go find the information. Keep going back to it. What am I looking for? Value between 4 and 4.5. That's how I got my shaded region. Okay? Yes, Key Anthony.
I'll be along with you telling you. So, listen, guys.
I don't even know. I don't need
These questions, man, when you're doing it work, you gotta go back and look in the book.
already
And the question ain't gonna tell you what
I'm
to do.
not listening to Keith.
Who are you telling? I had to tell you that.
Hey, but listen, at least I listen, right? I ain't asking questions.
Hey, she listened to?
You know what? Asking questions is not a bad thing, Keith.
Because it's just a giant puzzle to figure out, and I love
And
puzzles.
still not learning from it.
You know what?
It's a giant puzzle.
Can't talk.
And it's a
Like, I
language.
ask obvious questions.
I didn't get
But that doesn't mean it's not worth studying. Just because things are
Me personally, I
hard
ain't gonna let nobody say that.
just means
That
it's
was
a
a
better
genuine
challenge.
question. Y'all asking questions about stuff you can go back and look for.
How is it a better challenge when I'm crying over homework?
How about
That
we
is
all
for real.
sit?
First, man, listen, I can get up and hit him.
Okay? There's a good point I want to point out. Hey, quick question. How much is your GPA going to matter once you graduate high
A
school?
lot. I didn't know how to solve
That's what matters.
Hey, Madison, tell me this. Once you get to college, are you ever going to look at your high school GPA ever again?
No, but I needed to get into the college I want to get to.
What college you want to get into?
Notre Dame.
Stop. Here's the thing. Even if you don't get into the college necessarily that you want to, do you know what you're still going to do? You're still going to go to college.
True.
You know what you're going to end up doing at college? No.
Yanni.
You're going to get a degree, right?
Right.
But what if I don't get to the college I want?
Are you still going to get a degree in the field that you want to study? See, this is what high school students forget.
Next time,
It's,
about
Anthony, I'm talking.
So it's about the college.
It's not. The college that you go to doesn't matter. It doesn't. Because here's the thing. If you're a person aspiring to go to a place like Notre Dame or a person aspiring to go to Brown and things like that, chances are you're probably going to want to get a master's degree as well. And then it doesn't matter at all where your undergrad is. What matters is where your master's is. Beyond that, once you get into the job field, it doesn't matter at all where your degree came from because all that matters is your work experience and how well you do your work. And I understand that there's this mindset because other teachers have said this, parents say this, that you're university matters a ton. And you don't want to go to some universities because they might be really bad or they might not have the greatest instruction, things like that. But at the end of the day, what matters is your learning. Your GPA doesn't matter outside of high school. And like, I'm telling you this because I had a strong GPA in high school. It didn't matter a lick once I got to college. It didn't. You want to know how much your ACT score matters after you get into the college that you're going to? 0. You want to know how many people I heard talk about their ACT score once we were in college? 0 people. Because no one cares. It doesn't matter what the past is. What matters is what you're doing moving forward. And I know that the GPA matters, and you do want to look at your grades to see if you are learning well. But if you have a 4.7 GPA, which I knew people who did, if you have a 4.7 GPA, but then you have a 21 on the ACT, that doesn't jive. That doesn't make sense. If you have a 4.7 GPA, but it's just because you took easy classes, have you actually learned and gotten prepared for college? No. You got to remember that to make the important things. Yes, math can be hard, but it's also a giant puzzle. It's also very real world. Math is a language for mathematics. We're looking at this idea, which is goofy, but we're looking at Brad and Toby and trying to figure out who has a better chance of winning this contest. You can apply this in other situations once you understand how the normal distribution works. So this is why I study math. This is why I love math. Yeah, my undergrad's in civil engineering, but this is the foundation for all of it. This is why I was able to do things in engineering and able to appreciate it. You don't have a good education, it doesn't matter.
I want to be an engineer.
It's good. You better pay attention to how I teach then.
No, marketing. Marketing.
That's not an engineer.
I want to be a nurse practitioner.
Be a marketing engineer. I wrote a whole thing about it.
Okay. I didn't study engineering or anything, but let's continue. Okay, so looking at the probabilities, who is more likely to win?
Brad.
Right? Brad has a probability of 0.16 of having a golden tomato, whereas Toby only has a probability of 0.158.
Yeah,
And you would want to write about that in your final stuff. So, please hear me very clearly. Your education is what matters. The GPA, yes, it does matter so that you get into a decent college, but I'll go ahead and tell you, based on what I'm seeing, none of y'all are looking below 3.0 GPAs. And that's really the bottom line cutoff. I would imagine most of y'all are above a 3.5. You have above a 3.5 and you have good learning and a strong ACT score because they care more about your ACT to get in than they do about your GPA because some schools are way easier than others. For instance, what's an easier school around Tuscaloosa? No, sorry. Easier high school around Tuscaloosa. Oh. Central. Right. So let me ask you this. Listen. Would a person at Holtz or Bryant with a 4.0 GPA have learned more or maybe even less than a person who gets a 3.5 here?
They're trying to teach us math, but give us a life lesson.
No, I'm trying to give you a life lesson. Listen, this is important. Do you think that it means more earning a 4.0 at Bryant than it means getting a 3.5 here at Hillcrest?
Is this a statistical question?
No.
No. And that is my point, is that a 3.5 here is probably harder than a 4.0 at other schools. That's why colleges don't care that much about GPAs other than the bottom line as long as you have above a 3.5 for scholarships, things like that. And that's for scholarships. You can have way below that to get in. So what matters is your learning. Focus on that. I'm here to help support you on that. And I'm telling you this as someone who was very successful at the high school game of learning and doing whatever. It didn't matter what my GPA was. It mattered what I learned. I took hard classes in high school because I knew it was going to challenge me to learn more. It matters how much you learn. Let's look at the understanding check. Okay? Number 1 on the understanding check. Yeah, we're going to probably look at some of the homework later, but we're done for now. Okay, so looking at number 1 here, do you know what the number 1 issue was?
Everything.
No, number 1. And not, everything is not an answer. Emma, I didn't give you a copy. Did I give you a copy?
You did.
Okay.
I can see, because I actually made this mistake, of like, for number 1, the number of people attending was 8. I accidentally was about to put 0.8 instead of 0.08.
Okay?
That could be an issue.
So 1, maybe 0.8 versus 0.08. For someone who actually got this answer right though, what was the actual relative frequency? 0.16.
How you get it?